I, James, founded and work for HPI, but do not represent them or any of their opinions.
Welcome to Season 9, Episode 323 of the Furlo Bros Tech Podcast. Every week, we definitively answer one question about the future of tech. To do that, we take into account many factors, including the companies involved, the people working for them, their marketing campaigns, and of course, the technology they're developing. I'm Matthew Dean Furlo, and not checking out Apple's new AR Visitor Center is my brother, James Furlo.
No, I'm not.
Yeah,
and I didn't even know about that.
It's pretty sweet, man. You as you approach the campus, it just sort of looms over in the above houses and stuff. It rises above the horizon. And they've got this they got this cool new visitor center where you can buy any Apple product.
Of course.
They've got a terrace that you can go up on top of the roof, basically on the second floor, and look at the new campus. Wow. But one of the cool things they have is this big table. It's probably like 10 feet long by as many feet wide. And it's a scale model of the current campus with all the buildings and the spaceship and everything.
Cool.
But it's all white with a grid drawn on it. And they give you an iPad, and when you point the iPad at it, it locks onto the model and does an AR overlay, and then you can interact with it and see different times of day and interesting stuff. It's kind of neat. It's very, very high technology.
Very do it once-ish.
Yes.
And then James, move on with your life.
like most AR applications, it's a tech demo.
Yeah. Well, that sounds cool. I could see that application makes sense because that's what you're going to do. You're going to go once, and then you're going to bring your friend and go check this out.
Yeah,
and then
it's funny. I brought my girlfriend, and as we were driving away, she's like, "I'm really glad we did that." And I was like, "Yeah, good. Me too. I'm glad you did too. I'm glad you enjoyed it." She goes, "Yeah, because I'm sure the longer I put it off, the worse you were going to get about me putting it off." I was like, that's accurate enough.
Yeah.
But that's hey, you know what, James? In a way, that is what we're here to talk about this week, but not specifically. So this week's question is, what's the consequence of the Spectre flaw going to be? And
Spectre.
So what's your thoughts, James? What's
I liked the movie Spectre.
Yes,
so
right.
I know I'm not necessarily in the majority on that one. And I feel like they had a missed opportunity with the main bad guy there. But what can I say? I'm a classic Bond fan.
Yeah, I hear you.
I do feel like the ending was a little weak. I'll agree with that. There's all the suspense and it just kind of ended. But maybe he'll be back.
So there's this idea of like I actually don't know I don't know where the name Spectre came from. I think it is a James Bond reference, but
probably.
But we're not
really? I don't know.
Oh,
we're not talking about the movie. That's right.
We're not talking about the movie, James. We're talking about Intel's Nightmare.
Their own arch nemesis,
exactly.
Trying to kill them.
The Spectre Bug. So
yes.
So beginning of this year, we're going to talk about it a little bit because it can get a little bit confusing, and I'll try to keep it snappy and interesting. So I'm going to give you the lowdown first. This is the bad news. It's pretty bad news. So number one, this is an exploit, a bug, as it were. That can be, there's all sorts of different ways a hacker can get at it. The easiest for them would be to use JavaScript that you download in your browser. So by going to a website is the answer.
Any website.
Any website. And they could do, if they have the intent, they can do it. The worst case. That
seems bad.
Yeah, well, I mean, you wouldn't be, if there's a bug that, you can just download, going to any website can trigger this, it would be bad, but it's only really bad if the exploit, if all the exploit is it allows them to get your background picture, how big of a deal is that? But if it were something like it would allow them to access all of your kernel memory, including your root passwords, that would be an issue, right? I mean,
that sounds worse.
That's definitely what this allows you to do. So
perfect.
The worst case, though, and this is good news, the worst case situation where your kernel memory can be accessed can be mitigated through software fixes. But the downside to it is that there are severe performance hits, and depending on the application, it can be as little as like a 5% performance hit to as bad as like a 45% performance hit, depending on your application. But don't worry, that only affects things like internet database applications, which is pretty much what the entire internet is. So
perfect.
No big deal. And good news, like another good news would be this might only affect a certain small group of chips that you might not. Yeah, so this is the problem. Definitely affects Intel chips. Which Intel chips, you ask? Like all of them for like the last 20 years.
Excellent.
It also, unfortunately affects all ARM-based chips, which is literally all the rest of them. So Android,
this is pretty comprehensive.
AMD, Apple is having to push out fixes for the iPhone and the this is literally as bad as a bug like this can get. It can be accessed through it's kind of amazing as a technological achievement because it's OS independent, because pretty much anything that can connect to the internet can download JavaScript, can be executed. And because it affects, basically what's happening is because it affects the actual hardware, it's a hardware problem. It means that anything running that hardware, ultimately all the operating systems are interfaces for the hardware. So even though certain applications are going to do things differently on the software level, a hardware level, they all effectively do it the same way. So an exploit can be cross-platform.
Right.
Because they all use the same underlying hardware. CERT, which is which is America's big like emergency response team, computer emergency response team. Their original response when this came out was they said that the only fix was to get a new CPU. The dilemma being that there are no CPUs that don't have this issue yet. So
that doesn't really sound like a fix.
Yeah. So, and we're going to clarify a couple of terms here. Spectre, as we were talking about, is the particular type of attack. It's the vector of attack. It's like, it'd be like saying cancer. And then meltdown is like saying breast cancer. It's the specific type of cancer.
So meltdown is a subset of Spectre.
Yeah, Meltdown uses Spectre to get all of your kernel memory. So that's that's the lowdown. Okay, so we're gonna take it one step.
Wow, that's bad.
Yeah, it's real bad.
Are there any cases so far, like in the wild, hacks that have taken advantage of this and taken over stuff?
So there was a paper that was published that kind of set this whole thing off. That basically showed Meltdown working, but nobody knows at this point if anybody's ever successfully used this attack in order to actually penetrate stuff. This was discovered by Google's Project Zero originally.
Weren't there like 3 of them that were all within like 2 months of each other or something like that?
There turned out there was actually many different security groups that caught the problem during this period, but it was about 6 months ago, and Google Project Zero caught it first, found it first. So as far as we know, which is not much because it's very possible that Russia or China or the NSA knew about it and
would they? I guess they're actively looking for that kind of stuff.
Yep. I mean, So we're going to go a little bit deeper into how it actually works. A little bit of a technical explanation. So
I'm ready. Bring it.
All right. So CPUs, your central processing unit, generally speaking, they have to execute code. And how they execute code is they do it, your clock it's a beat, and it's a regular beat, and every beat you can execute one piece of code. That's an oversimplification of how it works, but for this example, that's fine. So what happens is there are certain things that it needs to do, and it can do that at whatever the rate of your clock speed is. So my computer is like 2.4 gigahertz, which means that it can do 2.4 billion instructions every second.
Okay.
The problem is that in order to do stuff, it has to get information. It has to figure out what to do and what to do it on. So the data, it gets that from RAM. RAM stores tons and tons of data. The problem is
Right.
RAM is very slow compared to a CPU. So what you end up with is you end up with if the CPU always the CPU would always be bottlenecked by RAM if there was another solution. So they came up with this other solution called a cache. You might have heard how much cache does CPU have. What cache is it's super fast RAM built into your CPU. So what happens is when your computer does stuff, it talks to the RAM, and instead of getting one piece of information from the RAM, it gets a huge block of information from the RAM, puts it into the cache, and then does stuff on the cache. And only until it gets a piece of information until it gets to something that it doesn't know the next answer to, that's the next time that it talks to RAM. And so that led to this idea of out-of-order execution and speculative execution, which is basically saying under certain circumstances, let's say you have a long list of names, and you tell the computer that a user can only access the first 15 of the 30 names. So as long as they're doing 0 through 15, they can get that information. But if you go over 13, they can't. Basically what happens is and then unless you're an admin, and then only admins can get the next chunk. Basically what happens is the cache will see that, maybe you want to get, it's essentially what you're able to do is if the cache doesn't know if you're the admin or not, the CPU will just give you the information it wants and store it in the cache. It won't give it to the user. It won't get anywhere. It'll finish doing what it was doing until it figures out if you're the admin or not. And then if you're the admin, it's already done the execution. If you're not the admin, then nothing.
It doesn't share the results.
It doesn't share the results. That's how it's supposed to work.
Okay.
That fact allows you to do, and that is what Spectre is.
Interesting. So it's pretending to be the admin.
It basically what happens is the cache has access. It can do stuff that it's not supposed to be able to do without proper checks. And that check can be, whether you're an admin, that check can just be an if-then statement. But the fact that happens allows for you to do certain way more technical stuff we're going to link a video by the Computer File channel on YouTube where they actually explain Spectre and Meltdown. Another one where they talk about how CPUs work and this out-of-order execution and stuff that kind of leads to this whole thing. But basically what happened was this is all like fundamental computer science.
It sounds like it.
This is stuff that all the competition, all CPU developers have been doing for the last couple of decades to get over the RAM bottleneck, which is why it affects everybody. And so this is kind of an issue. It gets worse because,
of course.
Because at this point, one of the security things that computer programs do is that they basically every program gets its own virtual memory. So one program can't access the virtual memory of another program. It's a security thing, right? And so if one program breaks, it won't give you access to another program, ideally within the cache. The problem is that all programs need things like the kernel, because the kernel controls stuff like accessing the hard drive.
Yeah.
So what they do is they would literally, each piece of memory space would be split half and half. One would have the program memory, one would have the kernel memory. So every program has access to the kernel memory.
Love it.
Yeah, and we just said that within the kernel, within the program space, you now have access to any memory within the kernel space if you know how to do this exploit. Well, now that includes the kernel space. So you literally have, and the other things that are stored within the kernel are like root passwords. So this is terrible. This is as bad as it could possibly get. And this is where the real issue comes. All the patches that everybody's pushing out, what they do is they basically separate the memory space, so that kernel memory is not stored with the program memory.
Okay.
But as we just said, every program uses the kernels. Some use it more than others, like databases that heavily use,
which is why the performance hit happens.
Yep. And then, yeah. And so, and the problem is that, so Meltdown, they're pretty sure is going to be patched and everything. But yeah, it's, you can't but if somebody could figure out how to exploit Chrome, for example, all of your passwords are stored in Chrome. So
totally.
So, if you could, theoretically, you could hit everybody, you could get somebody's bank password if it's stored within.
Yeah. Why not?
Now, I will say this. These are very difficult exploits to do. It's not easy and it's time consuming. So that's actually most of our biggest protection against it.
That's good. That's good. I'll take that. I'll take it. That's a win.
Yeah. But this is going to be one of those ones that are just going to be dogging us forever.
See, this is why I'm not worried about AI taking over our lives, because there's little things like this that are going to keep cropping up. So also, just almost barely related, I was coming home from doing some work last night and was chatting with my wife, and she was like, I want a chocolate sundae. I'm like, dude, I'm in. You gotta tell me twice. So I stopped at the old Mickey D's and I roll up to the window and they go, I'm sorry, our systems are down. We can't take any orders right now. Have a great night. I was like, wait, what? I don't understand. I mean, I didn't have any cash, so it was a done deal for me. But I was just like, they weren't even like, we're done. Computers don't work. And it's like, this is like just a weird little glimpse of potential futures where, yeah, everything works off these computers, and if something like this happens, boom, we all go down hard. Now, I totally understand the probability of this being a genuine problem for nobodies like you and me, pretty low. But you're still just man, it's crazy how, in some ways, how fragile the system actually is. Or these are things that, like you said, we've been doing them for, I don't know how many years, at least for 15 years, we know that Intel's been doing this. And it's just, like you said, it's a fundamental part. We don't question it. It's its thing. And we are more than happy to put in information and trust the system. And then you find out,
well, Intel's so unworried about it that they're so far along development of their next set of chips that they've already announced that they're not going to fix it for the next set of chips, because they're like, it's too late, we're too far along, it'll take too long to fix everything.
Oh my gosh.
I know.
And in some weird meeting, they're like, we can't say this publicly, but this is going to be awesome for sales.
Yeah. Yeah, exactly.
When we come up with a new one, let's remind everybody about this, okay?
Yeah. Let's make sure that everybody talks about how
this one doesn't melt down. La la la. I can see the commercial already.
I know. But so I did want to cover this really quickly because I thought this was interesting.
Before you cover it, we need to take a break here.
Yeah.
Who's this podcast supported by?
So this is
we gotta bring it up a level here.
Definitely. So this is brought to you by USB jump drives. Thankfully, they are hack proof. I mean, they can carry hacks. They're definitely a vector for bugs, but they are not themselves bugged, as they're just.
It's it could be a carrier, but won't ever get the sickness itself.
Think of your USB as a tick. It doesn't have Lyme disease. It's just going to give you Lyme disease.
Gotcha.
Oh, jeez. That's an awful.
And I would say a second sponsor of this podcast is probably going to be the movie Independence Day.
Yeah, right.
Because they also transmit viruses.
Yeah. Exactly.
Could it give it a cold?
Yeah, I mean, honestly, it's pretty much the same. That's the only way that virus could have worked is if it's a fundamental computer science thing.
Yeah, right? If you think about it, because it's alien technology.
Yeah.
Man, what were the chances? He probably used Meltdown, if you think about it, to get into their system.
This is totally unrelated, but there is a completely valid in-movie logic to why that worked. That the aliens were using our satellites to communicate. There was already an interface that they had set up that effectively allowed, they had opened themselves up to us communicating with them and making a bug. It's like, it's a completely...
Well, that's the same idea as me. Like, I'm visiting the internet, right? And I'm using a website. Like, I'm giving you permission. Oh, come on onto my machine. Run some JavaScript. Don't worry about it. It's the same idea.
It is actually a completely...
I kind of want to watch the movie now. So
I know.
Just think about this.
Don't watch the sequel, though. It's real bad.
You see, it's a problem when the doctor, what's his name? Kevorkian?
Yeah.
No.
Close enough.
Data. That's who I know him as.
Yeah.
When he's the star of the movie, you're like, geez, that should not be the case. Makes me a little concerned for Jurassic World Part 2 or whatever it's called.
You know what my expectations were low for the last one, so I got to go in with low expectations, and I think I'll be pretty happy.
Yeah, you should be fine. So, anyways, this podcast brought to you by
USB. So I want to talk about a little bit how this came out because it was kind of interesting. So we'll start at the end on January. It was like 8th or 9th. The register broke the story, and people hadn't pushed out patches yet. Things weren't ready to go.
Good job, register.
So how did we get there? Well, they made the argument that the story had already effectively broke. They were just kind of letting their readers know. So basically what happened was about 6 months ago, Google's Project Zero contacted Intel, AMD, and ARM and said, hey, we found this bug. Figure out who's affected by it and let them know so they can patch it. Google's Project Zero, generally speaking, only gives 90 days for you to patch it before they go and announce it before they go public. And they said, be really, really careful about who you tell. Well, those Intel, ARM, and AMD all started figuring out who would be affected and how big. They started telling people, and after a little while, it became obvious that it was just everybody, and it was horrible. So Google doubled, or Project Zero doubled to 180 days, the amount of time that they were going to give them. As you said, other security firms started to identify it, contact Intel, and Intel would get back to them right away, be like, yeah, we already know we're working on it. Please don't tell anybody. And freaking out.
That's crazy that they all kind of happen around the same time, though.
Yeah. Their CEO sold millions of dollars worth of shares right around the time that...
What? Yeah, I didn't know that.
Yeah.
Oh, that's shady beyond shady.
Super shady.
Dude, you don't...
I know.
Okay.
I know.
I hope it was just bad timing, and he's like, oh, this is going to look bad. As opposed to, he actually, was misconduct.
Yeah, I hope so, too, but... It looks real bad.
It does. Yeah, the optics are not fantastic.
And they basically had to coordinate with everybody on this. Amazon, Microsoft, Google, anybody with web services, Hewlett-Packard, Apple. Literally everybody had to get involved. And Linux. And the problem was that Linux is a open source project with public forums to discuss all this stuff.
Yeah.
So they had to figure out how to secretly patch this stuff publicly. And they did not do a great job of it.
You secretly patched this publicly.
Exactly.
Dude, how would you have loved to have sat in that particular meeting?
Well, see, that's the problem is they don't have meetings. They don't they just sort of all talk on the internet and work on it together. And, so stuff started to come out about,
or just, whatever, whoever that person is, who's we need to do this. Be like, how?
Linus, man, he's the dude. He's basically Linus, the guy who started the Linux. Linux. They went to him and said, "Hey, this is the deal," and he said, "Okay." And he personally wrote patches for this.
Wow. That's kind of cool.
And he pushed out a patch out. They're normally really good about pushing out patches on a particular schedule. He pushed out a patch out of schedule, and that's what everybody was. And it had a performance hit, an immediate performance hit. He was
boom, red flag.
Yeah, and everybody was like, "Wait a second!" So everybody started looking into it. That's
naturally
when it became apparent. People started accusing ARM of it, and ARM engineer was like, "Look, we're not affected by this bug," and everybody was like, "Wait, what bug?" What are you
yeah,
exactly.
Yes. I'm not affected by this bug. What bug?
Yeah, exactly.
That's classic.
And finally, the author for the register was just he was like, it's out there. You can see it on all the public forums. Just nobody's.
Yeah, if you know what to look for, it's there. Just you and me don't know it yet.
Yeah.
Wow.
And so he published an article before the embargo was lifted, and it was just a scattered cert. The
Wow. What a
response,
scoop.
yeah, the emergency response team, their statement of you have to replace your CPU. Intel hadn't notified them yet, which is why they found out with everybody else with the register
Oh
thing.
my
They've
gosh.
actually softened the language since then. And they were like, we probably would have softened it right away if Intel had given us a heads
Good
up.
job, Intel.
I know. Yeah, it was.
I mean, this isn't quite as bad as Samsung's little debacle, but man, this is bad.
I know.
Not
Yeah.
handled as well as it could have been.
Well, and there's a really good article from The Verge that talks about how do you keep a secret safe from the internet, and it's just because it's
don't.
Yeah, pretty much. And also Ars Technica is I have an article from them that does a pretty good job of kind of writing out the virtual memory space X part of it, and it's kind of I don't know, I think it's a fascinating bug. But what do you think is going to happen, James? Where do we go?
Nothing.
I think Intel got rid.
I mean, like you said, it's not the easiest thing to exploit, and so I think like normal people aren't. It's not going to be a problem, and they're going to come out with patches, and we're all going to get new phones in a year anyways. And so, I think you might have a couple isolated cases where something gets hacked, or it's like an individual person. I don't think you're going to have any like the massive security breaches.
Does Intel get sued? Does anybody?
Nah, I'm an optimist. Maybe, probably. They're probably gonna look into the CEO and his whole selling of shares thing. I hope that gets looked into. That's top of my list for shady activity. Everything else, you're like, dude, you've been doing it for 15 years. Like you just didn't know. You know what I mean? Like it seems like a genuine like oops.
Yeah,
I mean it's a bad oops. Don't get me wrong, but I'm like, what are you gonna do?
Well,
like,
and I think the fact that it's affected that the ARM architecture uses a speculative.
Yeah, it's not just Intel.
Exactly.
Yeah, exactly.
It's the idea that all computer scientists had agreed that this is the best way to increase performance.
Turns out not so much.
It's secure. Yeah, and it just was like, yeah, we were wrong about.
We were wrong. It happens. I get it. The Earth is round. It's not flat. So I think, I'm not worried about it. But
I want to meet the guy who figured this out. Was it like he accidentally did something and was like, whoa, that works.
This feels like it would be an amazing yet boring movie.
Right? Yeah, I know.
Or book or something like that.
Funny, I actually had a story that we're running late on time, but I had a story that it was interesting and I think it would have been pretty good. That kind of, but I actually think you could.
Way to tease something we're not going to.
I know.
Awesome. So there you go. So we got a question for you, dear listener. Are you concerned? Are you going to go out and get a new CPU when new ones are available? Does this change anything? Are you looking for patches? Like, I want to know what's your level of unease about this, and please share in a comment somewhere. Facebook, Twitter, on the website. We're pretty flexible on where you can comment. You can even comment on iTunes. We'll offer that. And we want to know what you think about this. Is it a problem or not? And on that note, we want to thank you for joining us. We really do appreciate it. You can check out all the links. We're going to have all the different stories that Matthew's talked about, so you can dive even deeper if you want to. That's going to be on Furlo Bros 323. Boom. You can subscribe on iTunes and Google Play. And we want to say thank you to The Verge. We had a couple people, Tom Warren, a guy named Brandon who doesn't have a last name, and then Ars Technica, which is Peter Bright, and then the Computer File folks, Dr. Steve Bagley, for contributing to this show. We really do appreciate all of their help. And this podcast is sponsored by listeners just like you. It's also sponsored by USB jump drives and the movie Independence Day. And so on that note, I am James Furlo, and my augmented reality brother is Matthew Furlo. And so we will talk next time.